Okay. Okay. Um just got to fix something. I had a crash. Something crashed. Just got to go get rid of that fake stream that started that crashed. Do 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 do. Okay. So, um I'm just gonna keep working on this because I didn't have a chance. I ended up having to do a bunch of farm stuff last night, so I didn't have a chance to get this done. But this morning I did do quite a bit of work, and I've managed to condense it down quite a bit smaller. So I'm liking where this is headed, but we still have some work to do. And it's just a matter of finessing these bits. What I need to figure out is how to make the I need to figure out how to make the hook happen a little more aggressively at a specific point. Because right now, I think this needs to come out front a bit. And I probably could be doing this more methodically. See, like, it's close, but it's just not quite there. It's just going to be a matter of getting these placed in the right spots. Love that. See how that flicks out? Beauty. But it travels too long. Okay, so I think what's happening here, obviously we're referencing that one, so let's change. I managed to get rid of some links as well. But this has obviously become quite a complicated little design. Look at that. Look at how that flicks in with the slightest amount of... So now considering that, it stops moving when these go vertical. It stops moving when these go vertical. I know there's a bunch of sketches and stuff going on, but like, ooh, that flicks in nice. Okay. So I'm going to actually move it closer here. What? It's okay. We can still test the mechanics with all that nonsense, right? Yeah. Oh, we're so close. We're so close. So as you can see, we're looking at the red guy. And so it doesn't move really at all horizontally between these two, which is great. Comes in and then starts to move down, but it's still a little slow. I'm getting confused by what I'm seeing here, though. It's all this nonsense. I also space things out so that they'll actually fit in the mechanism potentially. So close. Actually, this might be it. Let me just try one more thing. Well, I'm going to keep trying. Honestly, at this point, we may as well perfect this. wish there was a way I could hide sketches. Look at that red guy, though. It's not moving at all here. And then at this point, it does move. But it still takes a while for it to actually stop. Dun, dun. See, we're so close. Like, we just got to look at specific points, right? So I'm looking at this dot right here, this circle. When this moves down, between here and here, there's a ton of travel, which is great. And then as it moves down, okay. At this point, I need to change my geometries because it's really hard to tell what's happening here. So let's start by changing this guy. Boom, project, boom, boom. Okay, we don't need that guy anymore. Which is great. So we want to find the point at which the red guy stops moving in relation to the gray guy here. Right? So you can see here, it's moving in relation to the gray guy, and about here, it stops moving in relation to the gray guy. We need that relationship. We need it to stop moving relative at this point. Now, I don't know if I can do that directly with the red guy, but we have this link up here that I think we can potentially use. So let's go into, but I still want to, I think I can still compress this smaller. think that's awesome. That works pretty darn good. All right, clicks. Click. But it carries for so long after that. So, what's happening here? When this moves downwards, this gray thing's getting in the way so bad. We gotta change that. What's going on here? Why did this... We don't want any of this. We don't want any of this. There we go. Oh, actually, we don't want any of this either. Or any of... Well, that's fine, I guess. I don't know. That's just going to be there, but that's fine. We're just using this to understand. I just need to understand. So right now, obviously, that can't be going through that. It should be there. Yeah, it's good. Thank you. So one thing I'm noticing is we can really use, like, look at this tip, and it is kind of doing what we want. It's just in the wrong spot, obviously, but at this point, it's pushed as forward as possible. At this part, it's pulled way back. At this point, it's pushed as forward as possible, and then it rotates out. Which is what we want. But ideally not a rotation out. I want it to just go laterally in these two directions. So, what do we got to do here? We're so close. This mechanism's getting real tiny too, which I love. My question is, do we even need this joint? This additional joint? Like, what if we just moved that right on top of this one? What if? Let's see. We can test that out. Just doing that. Because the less screws and stuff we have, the better. Still works. Still works. And look at that. We're simplifying this, and that's what I love. This is getting simpler and simpler. This is getting simpler and simpler. So now, when we look at this, so if we're here, which is the point at which the jack releases, we pull up, that moves well out of the way. Oh, you know what? It actually didn't change. Can I literally move this? No. That is still referencing my link 5. See, if I just move this joint back, we might be in business. So let's get this link going. But what I'm going to do is I'm going to hide this body. Oh, it's already hidden. We're going to create a sketch on this surface. I'm going to project this and this. But instead of doing that link there, let's try it out here, see what happens. What is it, 4.8? Eight. So I'm also doing smaller screws for all of these as well. This doesn't matter. 8. 8. And who cares? I'm just going to speed through this. It doesn't need to be perfect. We can make it perfect later. And then we're going to extrude all of this. This is just going to be a new body. Finish. Okay, so you can see we have, when we rotate this, the only joint that's stayed is this one, which we'll get rid of. Delete. Yeah, so now let's do a joint between these two. At that point, yeah. What is this going to do for us? What is this going to do for us? Okay. I think we're basically there. See what I mean? So we come here, obviously assume this is here on the upswing. Now we're going to be looking at this hole here, or I guess the edge of this hole. When this swings forward, oh no, maybe that's not. God, I thought we were close. Hey Rosenberg, how you doing? I'm struggling hard, I will admit, but I think it'll be so cool. I think it could be so cool. I never watched Ted Lasso. I hear it's great though. I gotta get on that. I just need this. That sounds like a good combo. That is sort of the balance you need to strike, I think. That's what a good show does. I'm just struggling with I don't know how much of this whole project are you familiar with? Um cuz maybe me describing what I need to figure out will help. But I'm not too it makes I need to know where you're at on this project. But in short, it's just understanding how to program perfect linkages. That's basically the. So do you know that this is like a kick drum pedal that I'm sort of reverse engineering a piano key mechanism and adapting it to a kick drum pedal? Are you familiar with like that basic idea of what this is? Just from the other day, you were working on the smallest bass drum. You modeled a piano hammer initially. Okay, yeah. So, um, we're putting a pause on the smallest bass drum while I figure this out because I think this will be a step towards making that happen. And basically, my whole mindset is the smallest kick drum will only work if you can't bury the beater. So when you're drumming, and I am a drummer that likes to bury a beater. So you have the skin here, you press the pedal, and the beater hits the skin. But if you hold your foot down, the beater doesn't leave the skin. It just hits it and sits there. Um, Other people will play it and actually bounce the beater like that. And it's mostly a feel difference because on a giant kick drum, it doesn't make that big of a tonal difference because obviously when you bury the beater, you prevent the skin from resonating back and forth. But because a bass drum's so big, there's still a lot of other material that resonates at low frequencies. So on a regular bass drum, it's not that big of a deal, but there is a difference. And so people that bury the beater, so for example, I was in a recording situation and I play more comfortably, like I play heel up. And so it's more comfortable for me to bury the beater until the next strike. And this is just, it's a style of playing. But in that recording scenario, the engineer was like, it sounds so much better if you don't bury the beater. So I had to change my style of playing to do this instead, which was fine. It wasn't like a super hard part, so it was pretty easy to just change the way I play. But there's a lot of drummers that either prefer to play beater buried as a feel thing, or it's just a lot of people just don't have the technique to bounce it. And this is technically the proper technique for a kick drum. Okay, good. So I wanted to make a kick. So I personally play beater buried, and I was realizing that in the world's smallest kick drum, where the thing that you hit will have to provide 100% of the low resonance frequency to the sound, and if you bury a beater into that, you get zero low frequency sound. So I needed to make a kick drum that you can't bury the beater, because like I don't know what the ratio is, but I'm assuming it's like a lot of like even 50% of people bury the beater. So then I realized, okay, if I need to make a pedal that doesn't bury, it needs to somehow whack and bounce off on its own, even if you have the pedal depressed fully. And then I realized that's exactly what a piano key does. And when you hit a piano key, instead of staying on the string, it bounces off like this. And so we've done that. So you could see here, I'm pressing and I'm holding it, and it actually does retract the beater automatically. So this is working. This is step number 1 to making a kick drum pedal that works like a piano mechanism. Now, the difficult part is when the beater retracts. So it's got this little jack here. So this little jack piece here, let me get into a better camera view. So this little jack piece interacts with the beater, which is on its own independent bearing. And the jack piece works great. And once it gets to this point, it hits this like little plastic nubbin and actually pops the jack up out of the way. And that's what allows the beater to retract. But if I were to just let go now the beater is not, now the jack isn't underneath the beater anymore. Right? And so now it is. So what I need is I need a device, and on a piano key it's like called the catch. And basically what it needs to do is it needs to come in at the moment that the jack is lifted up, and you can see I have this piece here. This was like my little test piece. And this piece needs to be fully retracted as well when you have the pedal fully pressed. But as you release on the pedal, this piece needs to come up and press on the hammer or the beater and re-engage the jack, so that you can go for another strike right away instead of having to wait for the whole thing to retract again. And this is why on a piano you can hit a piano key as fast as you can, because it keeps resetting the jack every time. And it resets the jack like at like, maybe 10% of the pedal coming back. So that's all kind of smart or it's kind of easy in theory. But in order to make the mechanism that actually presses this back in, it needs to fully retract, fully get out of the way. And I calculated this from this point to this point is only about 11 degrees of rotation of this whole system. And then for the remaining 80 degrees, this can't push in anymore. This needs to stop pushing in at that point. So for the remaining 80 degrees of rotation, it can't do anything. It can technically, if we want it to, it could start rotating outwards again, but it just needs to hit the closest point. It needs to press in the most amount at that specific 11.2 degrees. So did a bunch of just fooling around trying to figure this out. I made cardboard models. I did all this stuff. Eventually I found this software called Motion Gen that lets you Found the software called MotionGen that lets you sort of plan out linkages, you know, and it shows you the path. And what I was looking for was this hook path. So this path comes up and hooks out right at the end and then comes back in. And so I took this MotionGen thing. You can see how it kind of works. So we're tracing this point and it comes up and flips out. So I took that and started bringing it into my design. And obviously with my design, I have very, very specific spatial constraints and very specific sort of strength constraints I need to think of. And so we're really close. I've got it now. It used to stick out like way out here. And like yesterday, it was sticking out way out here. And I've managed today to bring it and get it real compact. And you can see at this point, we're very close to getting that motion that we want. Right here at this point, you can see the red piece stops moving, and actually at a certain point, it does start to go back in the other direction. So we're very close, but the travel is still too much. So when looking at, I like to reference this specific point on the cam when it is, wait, I actually have a drawing that is useful for this. Yeah, so when this screw is in line with this horizontal line, this is where I need whatever is here pushing, because theoretically this is going to be like rotated back. So at this point in the cam's rotation, where this is horizontal, perfectly horizontal, whatever is pushing the jack or whatever is pushing the hammer needs to push it to exactly this point. And then as we rotate further, it needs to stop pushing the blue part in. And we're very close. And then as the screw gets past this horizontal point, as it gets past the horizontal point, it needs to shoot backwards. What's going on?
She escaped, so I tried her and put her back.
Oh, okay. How's she looking? Good. Okay, sweet. Yeah, so the real issue is the chaos of linkages. And so like when we're looking at this linkage, you can see every little move, that every little adjustment I make moves everything and affects everything. So it's just the chaos of linkages, and there is software out there that lets you sort of plan these linkages. But it's not easy to use, and I just get kind of stubborn when it comes to this sort of stuff. I want to like understand it in my brain. I don't want to just like, I don't know. I just didn't think that I needed to figure this all out. But unfortunately, every little adjustment I make here has kind of a drastic effect, or like in some cases has no effect. So I've just been really just kind of guessing, just playing around with this until I can figure out exactly what I need to do. Yeah, exactly. And it's funny because there's so many other things I could have done. I didn't have to do a linkage because theoretically this jack, where's the jack at? Yeah, the jack here is not actuated by a linkage. The jack is actuated by hitting a little stick here. And then when it hits it, the jack actually lifts up. And that works because I have a spring or an elastic wrapped around the jack and the hammer, and that works really well. And theoretically, I could just do that exact same mechanism for this. The problem is, because this already has a spring that's connected to this and everything like that, this would also need a spring, and it would have to be like a more powerful spring. And so adding additional springs, now I'm adding more resistance to the entire pedal, and I want this to feel as smooth as possible. It's like you have used another band in the opposite direction. Well, it wouldn't be. It actually, what's crazy is it's not. It doesn't need to be in the opposite direction. It almost is doing the exact same thing as the jack. It just needs to do it on a delay. It needs to do it at a slightly different time. So that was the other thing too. If I wanted to do it that way, where this part actually contacted something, the way the jack is contacting something here, it would have to contact it at a different time. And I don't want you to hit the pedal and feel like click, click, click as you're hitting the pedal. I want it to be as smooth as possible. And this is such a small thing. It's fine, but this actually requires a little bit more force to be able to push the mallet back underneath the jack. So, and I wanted to do something different. I wanted to have the mechanism be a little more elegant than that. And so the nice thing about linkages is, if it works right and it's working smoothly, you won't feel the linkage doing anything. Theoretically, it's just rotating parts. So ideally, the linkage will allow this to be a much smoother operation, and will let us, and it'll just look so damn cool. Like, if this is, if we can have this functioning, this looks so cool. So that's kind of where I'm at. I'm also trying to reduce the number of screws, reduce the number of parts. And so, like, what's cool is, in my little demo, you can push underneath the jack, and I think that's a really elegant way to do it. And so I'm wondering if there's a way I can actually, because all these parts operate off of this one big screw here, the jack, and then like a lot of these individual pieces. And so I'm wondering if we can reuse that again for this final piece that actually pushes the hammer back into position. But it's just a matter of messing around with this. I don't need the jack anymore. I was thinking about doing a circular thing too. And the reason I struggle with it is because the way this jack works, I had to add this little lip here on the hammer butt. This is called the hammer butt, where the jack interacts with the hammer. I had to put that little lip there because any other way I did it, the centrifugal force was just launching the jack out of place. So this kind of captures the jack. The problem with this is I need to push this when I want to get the jack back under. I need to push this past the point that the jack actually sits, so that this then clicks back in. So there's this much leeway here, right? In order to get the jack back underneath, you have to push it back a little bit further, and then it clicks back into place. The problem with doing a circular thing is, no matter how I do it, in order to push it back that extra little amount, that means the actual pusher, and so if it's circular, the actual pusher has to push this out, and then somehow it has to come back in. And then on top of that, if you can figure that out, so let's say it's a cam, like it's an egg shape, and so it pushes it out and then it comes back in. On the way back, it'll have to do that again. And so I want to avoid having to do that again. So that was the reason I didn't want to do a circular thing, because you're going to feel that on the way back. And I want to reduce as much kind of weird mechanical feel to this. I want this to feel as smooth as humanly possible. And like a piano key is so smooth, right? Um, what is really cool about this, sorry, I peaked that mic so hard. What is really cool about this is I've been playing around with just the version I have now, and the way that it launches the pedal forward is actually such a satisfying thing, and it feels different than a regular kick drum because you can now like you don't even have to press the pedal all the way. You can tap it and throw the hammer into the skin. And I don't know if that's going to be something I'll enjoy while I'm actually playing the drum. But I was, we were just sitting outside listening to music the other day, and I had this hit in a bucket, and I was playing around with the music, and the ability to launch the beater into the skin without pressing the pedal down all the way is actually like a pretty nice feature, I think. We'll see when I get this on an actual kick drum, because I couldn't really play this properly without the piece that retracts it. So I was kind of just fooling around, just making sure the feel was right, and it feels right, and there's even a little bit of it feeling like maybe something new, On top of this, once I get this all figured out, I will be able to add a damper as well. So like on a piano, when you do let go of the key, a damper comes and hits the string and stops the noise. And so I'll be able to add that same mechanism so that you can strike the kick drum, hold your foot down, and then decide when the resonance of the kick drum shuts off, which you can't do with a regular kick drum. With a regular kick drum, you either hit it and let it fully resonate, or hit it and bury the beater, and you get the least amount of resonance. But this way, you'll be able to hit it and let it resonate, and then stop the resonance before you even hit it again. So I'm thinking this could actually add a level of nuance to the playing. It's just like, it might be one little extra bit of style you can throw into your playing, because all of a sudden it's like, yeah, it's a little bit novel. It'll be so subtle. 99% of people won't notice it, but if you're like, I feel like as a drummer, you'll really notice that. So that's something I'm really excited for. And then with that mechanism, you could maybe connect this to a cymbal or like just a sheet of metal, and hit something that actually really resonates a lot. And then you have control over when, it's literally just a piano key, but operated by your foot. And I think it's cool. But I think the absolute coolest part about this is just the way this mechanism looks so far. And I think it's going to look even cooler when it's done. I'm going to print it in all these different colors, I think. And yeah, I just want this to look like the craziest thing. Because I think that's kind of the key to YouTube, is it's got to look good, and that's something I haven't really done. Yeah, totally. Obviously, having a proper double kick drum version of this where it hits the same drum would be insane. I don't even know how physically wide that would have to be. But you could just have two kick drums like Joey Jordison or whatever. Yeah, I think it'll be cool to do just a bunch of primary colors, just so you can really see what's going on. Okay, but anyways, I'm gonna try. I've been trying to figure this out for like 3 days, and I've been working on this specific thing for the last few hours. Today and a bit yesterday. So I want to nail this. It's so close. Where's my catch mechanism? Let's maybe turn this guy on again. I'm gonna go to sleep at 6 a.m. in Thailand. Holy. Awesome, man. Well, it's so cool to have you join. I believe. Thank you. I need that. Um, you kill it with your clients as well, and have a good sleep. But hopefully we'll get this sorted out today, and I'll have a functioning pedal uh, next time you join. Appreciate it. You take it easy. Nice. This is maybe it. This is maybe it. Now looking at this, we get rid of this, right? We get rid of that. Well, sort of. I'm so confused, but this is gonna be good. This is a hell of a lot simpler, too. At this point, it starts. I just gotta print something here. Okay, I gotta think about the strength. So, obviously, this comes through here. That is strong. This is strong. That's okay strength-wise. Ooh. Ooh, we can get real sassy with this. Because if I sing songs that I know, do I get banned or do I get struck? I don't know. Okay, so here's what we're gonna do. This is beauty engineering. This is beauty engineering. So let's hide this, hide this, hide this. So you could see my bearing sits on a little bearing housing because the bearing's much bigger than the axle. Now, what I'm going to do is I'm going to incorporate this right into this piece. And so we're going to go boom. Nice. I'm going to do this. I'm just going to build it all again because this is a different component. So it's going to be real saucy with me. So let's get this outer circle on there. Okay. Extrude this. What thickness did I do for this? 0.5 mils. We're just going to go new body, and then I'm going to combine them here. And then we're going to sketch again. We're going to project this. There, now this arm is so strong because it has all of this connection to the axle. $12.75. Oh. I need to project this guy as well. Okay. 12.75. New body. Combine this with this. Okay, awesome. Let's throw a Philly on here so this doesn't look so bad. Okay, so that is awesome. Now, this is the main cam. Okay, that looks good. That looks good. Now our jack, or let's bring stuff back. So on top of this, we have our bearing fitting. Or it's actually that's actually just the bearing. Oh no, that I'm so confused. Doesn't matter. Okay. And then we have another bearing that goes over that, which is great. And then we can close this up. Okay, we can close this up. Now this bearing on there and the cam. So that's on there nice. That's strong. We're losing this a bit. So I'm going to have to cut away at that to fit this guy. But is this the best spot for this? Maybe this should move over here. No, I don't think it can because we're going to have forces acting against the screw here. So the further this is away from there, the worse it's going to be. So we can't do that. That's okay. Let's close link 6. Let's close link 4. Link 3 we've got here. And then link 5. Right now it's this. Oh yeah, and I'm thinking about copying this over. Right, so we can make this guy fat and have it actually come over here so that it's super thick. You know what? Instead of doing that, okay, I'm getting ahead of myself here. I need to make sure that this is perfect already before I start finalizing things. So that's looking good. This is in a good spot. We're going to really easily be able to mount that to something. Now, we look at this. If I bring this in, will that work faster? Let's see. Capture position. Open this sketch. Okay, it's not letting me move that because it's coupled to that, I guess. Frustrating. Frustrating. And I really want to look at my main pedal here. Because everything up to exactly 90 degrees and then it's literally the tiniest little bit and it needs to fall back. What is that angle? I need to find that angle. I know I say stuff and it probably doesn't make sense if you're like just viewing this. Is that the angle? And it doesn't have to fall back that far. It could fall back this far. That would be fine. But yeah, it's about that, I would say. So it needs to fall back that amount in like the tiniest amount, like that much, which it's not doing. You know what I mean? Like we need to go Like, let's use this dot, for example, because it's right on the point where we want that to be. And we're talking like that much. How much movement are we getting out of this? Okay, let's just go to the bottom of the screw is the point. That's how much movement we got here. It's not enough. That's kind of what I was thinking it was, but it's actually only a tiny little bit. So what's happening here? This needs to be fully horizontal at this point. So can we do that? How can we make that pull in faster? From here to here. From here to here. Okay, I see. See how it starts to flip in at that point? That's what we want. We want to capture that, but between here and here. So at this point, that needs to be perfectly horizontal. Okay. Let's see. Can we make that happen? Let's see. Okay, so that kicks back. That's what we like. Now you can see it actually doesn't let me kick back further than that, which is probably okay. But now the travel is like a long time before it slows down. We're so close. We're so close. This is really nice. Almost. But then it travels way too much inwards. That's what we want, though. Shoot, and then stick back. Stick back. I'm going to bring this up just the slightest little bit. Because I want this to be able to come. There we go. Oh, no, that's perfect. So it stops there. Yep. Shoom. Shoom. Right, so what is happening here? Oh God, this is hard on my. I need to sit different. I need to sit like that gamer guy on South Park. That's just like this. I think this is good. This is ideal posture. So it has to wait for it to come all the way around before it starts coming down, which is not ideal. So how can I harness that? In a way that doesn't keep. Because see, if I have a triangle piece that sticks off here, of these two, that would amplify that, so now it would stick way out here. But then, as this comes down, it would swing in, and now at this point, it's like way in here, which is bad. Can't have that. But you can kind of see something here happening on this triangular piece. Okay, let's edit this guy. God, this is hard. This is hard, everybody. Someone's gonna have to show me how to do this properly because I am not wanting to ever do it like this again. Wait, what is... Okay, so this obviously is not actually connected to anything. So I need this to be the closest spot. Actually, like... Let's hide this body for a second. Oh no, let's bring it back. Let's sketch on this surface. Now we can hide this body. We know it's going to take this circle as one joint and this circle as another joint. And looking at this, we're basically at the closest point. So if we did do Huh? No. So just making an assumption here. Oh, my stomach. this back to there. And what I'm going to do is on this surface, which is, what is that? That's external 2. Okay, now we can look at that. Finish. What sketch do I got open here? Why can I? There we go. So now, what happens here? Okay, well that can't go further down, so that's okay. Oh. Wait, that's not okay. That's... Okay, that goes right into the cam there. But let's keep trying this. Let's see what happens. So theoretically that pushes it out. No, see, that doesn't really work. It can't be... So like in order for this to work, this pushes on that, but then when we get up to the point where it releases, it has to pass that and let this fall back. And then when this comes down, it has to push on that, but then it has to release it and let go. And we can't have that because it can't be nicking it every time. It can't be nicking it every time. So that doesn't work. Push. It also can't push it out of the way of the jack on the way up. That's the other thing. It's literally just got to come in, hold it, and then release. That's why this is so complicated. It needs to come in, hold it, and release. So what's happening here? How do we speed this up? I need to harness whatever that motion is. And then at this point, this has to be in the furthest. And then it's got to start backing out again. But the problem is, right now, as this goes down, it's not going down with everything else. It continues to rotate. Because it waits for that to go. So that doesn't work. What if we bring this in further? God, I'm losing my mind on this. It's going to be so cool, though. What if we went like, what is happening? Here? Don't know what that's going to do. It's probably going to screw everything up. It didn't screw everything up. What did that actually change, though? Where's our joints? The joint is still in the same spot. So it didn't change anything. This works in giving us till this point. Now it's retracted, but we want it to be even closer than that. Okay, let's. Oh, God. Okay, let's try this. This is kind of a crazy spot. Does that change anything? No, it doesn't look like it does. No, it's the exact same, so. I need to move this guy, but it's not letting me right now for some reason. Let's see if we can figure that out. Is it because of this sketch? Oh, maybe it's this sketch. Yes. That's so good. But it just keeps traveling in. Okay, let's keep moving it. Who knows? Okay, let's move this up. I wish it wasn't referencing so many stupid things. Oh my god. Is it referencing itself? I think it's referencing itself, which is dumb. Okay, well, I'm just going to bring this up. And then move my joint. Look at this thing. This is getting insane. That's looking good, though. Oh, but down here it starts to pull it back in again. Oh, wait. It's not this guy. Because I referenced the other joint. So we can edit that joint by editing this body. that body. Oh, okay. Here's what I'm going to do. Delete this joint again and reapply it between these two, but we're going to reference this now. Now I can move this guy. Try it out here. See that? So the joint is between these two. It's hard to see. Problem is, once we get to this point, it wants to carry on through that whole cycle. So we want to reduce that amount of travel. So to do that, we want to move inwards and upwards. Okay, this is interesting because this is now let's just hide this. We don't need this because that's obviously not what we're playing with here. Oh, this is so close. See how this circle, or this joint specifically, see how when we get up here, it pulls way back and then it launches forward super fast. Launches forward super fast. And then it starts climbing back at this point. Spend multiple hours a day on this. don't understand why the joint moved all the way out there. We're so close. Why does that stop? Why is that stopping? What is preventing that? Okay, let's hide a bunch of stuff. Let's hide a bunch of stuff. I don't understand. Like, this joint is just referencing nothingness. It's really annoying. Ooh. That's a lot of action. We can have it. Then it presses in and pulls back. See that? So we're just dealing with joints here. Let's say we're lined up there. Yeah, this would start to push in real hard. Way past where we need to go. Way past where we need to go. Okay, wait, let's reference this back line of this circle. So as we come down, boom. So this ends up there-ish. That's nice. Boom. This ends up there-ish. So now we get the jack back. But it's still traveling. Still traveling. At that point it stops. Okay. I don't fully understand what's happening with this thing. Like where the joint is ending up, it's random. Why does this stop? I don't recommend designing like this. Okay. Oh, that's not bad. Oh, shit. Let's hide these sketches, hide these sketches. I'm confused. Are these connected? I think so. Like that's three. There's three joints there. Can we just make this motion smaller by bumping up our this guy? Okay, so at this point, let's say this guy's to the center of that line, which is back a decent amount. And then as we swing forward, pushes our guy there. But then it keeps pushing our guy. We're so close. Okay. Okay, I don't fully understand what's happening here. Yeah, it's not until these are perpendicular, this axle, or this point and this point, the line that that creates is perpendicular with that, that this stops coming in. So we got to make it so that that's perpendicular at this point. I think I've done this a million times already. But I feel like we are getting closer. So if we bring this down here. It's not until this point that it starts really clicking into place. That's because we need this link to sit much higher up. Okay. Oh, I feel like we were so much closer before I started really messing with this. Okay, let me analyze what's going on here. So we've got a joint back here to there, and then we've got basically two going on there. So this is it, I think. But we can bring this down. And bring this in. But then if we bring this way in, what is happening here? So we've got the short little guy, long guy, and that's a 4-bar linkage right there. And then it triangles out. Okay. I see. So this one delete. And then we've got this sticking out like this, and then we have a link between this. Oops. A link between these two. Okay. Then we have a link between these two. We are getting a nice arc there. It's the wrong way. Love that. So how can we create that up top? Interesting. This doesn't change it. Yeah, we've lost our nice I'm undoing a bunch if I can. I should have saved. It's frozen. Okay. So what do we have? When this is at its vertical most point, we do have another arm that's shorter. This guy's connected there. This guy's connected there. I love that. No, but that's dumb. Yeah, I don't want it to do that spin, which it's not doing in my model at all. The spin is weird. Spin is weird, so what's happening here? I gotta turn this body on, I think. No, this body. Maybe slightly understand this better. So we've got a little triangle between these two. And then this is connected to that one. So we've got a little triangle. So doot, 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 doot. This one's on the inside. Let's get this here. Let's get this here. Let's get this here. And then I have a separate link between the edge of this triangle to that guy. Yes. And then this guy's above. Those are almost in line at that point. So why am I getting a totally different experience from this? That's weird, isn't it? Isn't this like pretty close to what I got? When this is down, okay, let's put this at horizontal. That's slightly bigger and that's inwards. So when that's horizontal, this is inwards and that's slightly bigger. That is now above that point. And this one is almost in line. Okay, I see why this is so confusing. Because it's not the path that I'm looking at. It's not the actual path that I'm looking at. It's the relationship between the cam parts, the parts that are rotating, and how that works with this. So is there a scenario I can find where these squeeze together at the point? Okay, so we want these to basically be as close as possible, but then we need them to, yeah, so they travel like this together, and then at the very end, they separate. It's actually easier playing around with this, I think. So what do we got here? That's really nice. So when we're looking at this, we can kind of assume like when that's like that, we need this. We need this to be close. Right? That's the goal. Yeah, closer, the better. And then they need to separate, and they need to be fully separated at this point. No. So they need to be ultra close together, right there, and then whoop, separate at that point. So, thinking of that, let's get rid of this. Let's get rid of this. I need this. God, this is hard. Oh, so stupid. So these need to be close together. And then at this point, we can bring this here. So this is the opposite of what we need. Really trying to understand what the heck is going on here. So this like this. Okay, at this exact point is when these bars need to be the closest together. So let's just assume, let's just put this here. Let's put this here. Once it goes past that point, so like this is an inflection point, but we can make the inflection point like there. Okay, no, not quite. When this gets to that point, it's close, and then it needs to shoot it out. So if this is like this, in every other situation. Okay, wait, what if we added a point here? Oops. Oops. Jesus. God, I gotta figure this out soon. I'm running out of time, folks. I think ultimately we are looking for that hook, though, because the hook is what's gonna actually make this work. So let's just look for a hook between this. Yeah, and then chook. Like, this is working pretty good. I don't know why I can't recreate this. So that's where that lines up. So that's why it can't go further than that. So let's make it so it can go a little bit further than that. Nice. Those need to stop spreading at that point. So click. Can't. Click. We're so close. I can't even. It's insane the amount of work this takes, though. What each of these links has to go through. I don't even know what happened there. Okay, that did move my joint in. It's so annoying that I have to go into each one to adjust them. Okay, now what if I just made that smaller? So keep the height the exact same, but just bring this in there. Okay. I'm into that. Still only reloading at that point. Come on, we got this, we got this, we got this. Starting to actually understand what the deal with this thing is. It's never going to go that far up. But that's working pretty good. That will allow for a beater position of this on traction. That's not bad. I can work with that. Now, realistically, what is this guy doing? What is our top bar doing? Okay, so this is kind of assuming, like, what is the top bar rigid? So that's vertical, just about, and slightly off. And then what is that doing? That just connects to that part. That's it. It's not working though. No, so that's not what's happening. This is we can kind of look at it like this, I guess. Why am I not seeing this? Why am I not seeing this? So do we just have a tiny link going from here to here and then from here to here? Okay, so this guy is linked to that guy, is linked to that guy, is linked to that guy. So that's a 4-bar linkage. This guy is linked to that guy. But I think ultimately this guy's just linked to that guy. This is really hard to visualize. Like, I think ultimately what we have is this. Oh, no. Oh my God. Delete, delete, delete. So I think ultimately what we have is this. No, that can't work. It's got to be like this. Add a point. Boom. It's got to be pivoting somewhere else here. I don't understand. What am I not seeing? You know what I mean? Like, there's two joints here. But they don't look like they're actually doing anything. I guess the relationship between these okay, yeah, so this is a little triangle. So we've got that, we've got that, we've got that, that, and that. No, that can't be right. Oh, we've got a tiny little arm that goes between here and here and here and here. Okay. So that's how that's working. Now, let's play around with this a bit. Let's figure out. If only this showed me, because I don't need this. I don't need to see the travel. I need to see how these separate. But I guess we can do that by going with a node here and bringing it way out. Now we can play with this. Okay. So then by doing that, if we increase this, oh, we got rain, folks. So that launches that out forward. So if we bring this here, so we're looking for the distance between these two. And I want it to spread out hard. When we get up. I want it to close in when we get in. So to close this in, okay, you see what I mean? Like this needs to work with this bar in a way that when we get to this horizontal situation, it pushes these apart. But then as So I need these to be really close together, or relatively close together. And this is wacky. I mean, that does it, doesn't it? But then it also does it there. But look at that. It goes shoot and then shoots apart. Because on this one, oh, no, I need them super close together at the top part, and then they need to split apart and then stay apart. Okay, so I had this backwards. So this might be easier. So I need them far apart here, and then they're going to get close together. So far apart here, and then when this comes up that much, I need this to get really close. Okay, so with that in mind, no, that's the opposite. That's launching them apart. We need to do the opposite of that. I need it so at, oh shit. I need it so when they're at this point, these bars are pretty far apart. Okay, yeah, so I need it to stop this whole thing. So, okay, that's getting better. Let's move this up. Let's make it even between those two so that that can really push this out. Shoop. Okay, I think I'm starting to understand this. So at this point, so we bring this up here. Okay. When this goes down, I want it to be able to compensate for that. Shoop. Yeah, so we need that scissor action. So need them pretty far apart. At that point, they need to be the farthest apart, and then at that point, they need to be the closest. But I needed to... Okay, so then let's bring this down. Because at this point, they need to be the farthest apart. So it makes sense that these would be like that. I need these to snap closed. Shoop. Okay, that's close. So what's happening here? Okay, I can get rid of this guy. This guy's just... So what's happening here? That can all buckle. So at this point, holy, 3 hours. At this point, okay, this might be it. So from here to here is the closest point. From here to here is the longest point. So how do we make that happen sooner? And then it backs off. That's exactly what I want. How do we make that snappier? Bring that out. But if I bring it out, then the widest point's here. So let's bring this in. Let's make that actually the widest point. So basically we want at this point there to be a 90-degree angle. Okay, so if we model off of this, when this is horizontal, this needs to start pushing against this bar that pulls these together. And we need this set at our maximum value. So when this is at a horizontal angle, so right now I'm pushing at the top of the bar, so that would be the equivalent of doing this. Very subtle. But instead, we're going to bring it down and out. So let's do that. And now at this point, we've got basically horizontal there. we need it so that at this point that's maxed. How do we determine what makes it max? It's actually not that's max, so we need to change this anyways. Can we just bring this in? That's the issue. That is the widest part. But then it stays up there for so long. Bring that closer. Bring this up and out. Okay, here's what I'm going to do as well. I'm going to add a point here. Let me use this as a reference. There we go. I'm starting to understand how to do this. So now, because that is what we are referencing. What matters is the distance between these two. The distance between these two is what we're tracking. And I want it when, yeah, I want that distance to just spread out at this point. Then when we get mostly horizontal, I want them to be at the closest point, which we are getting there. It's okay if it touches. See that? That's looking pretty good. That's the farthest point. That's the closest point. So I need it when it goes down to pull that arm in. Now, how do I optimize this? What does pulling this down do? It makes it a little more subtle. So what does bringing this up do? Makes it not work. What does bringing this out do? Bringing it out makes it subtler. So bringing it in makes it more aggressive, but I can only bring it in a certain amount. But if I bring it up and in, what if I bring this out further? Okay, that's pretty good. Like that. Look at the travel between those two at that point. That's good travel. And then as we come down, it closes in nice. It does close in like twice, and I'm a little concerned that's going to push it out of the jack at that point. So, what do we have here? That is a great amount of movement there. So theoretically, if I were to pull this out, to there. Okay, we broke. Why do we break? Because now that can pass. So why do we break? Because this was too far out. That's what happened. We hit that point. So we just got to come back in the tiniest little bit. If I could turn back time. No, we're still breaking. Breaking. So I think I made that too long. So what do we do to fix that? I think we come in a little bit. Now we're dealing with the tiniest little movements. Still breaks. Jesus Christ. Okay, why are we breaking here? Let's move our link 4. In slightly and lower, maybe. Tiny little movements. Okay, it's because that now, yeah, this is just too long now. So I'm going to call it here in a second, and then I really got to finish up my other video. I don't know what I'm going to do, but this is taking so long. I'm going to work on this tonight, I think, in bed. Nice, okay. And then once this gets to this point, it moves out of the way. And then pushes it in. So it's looking like we're going to get at this point. It's going to push it in, so looking at our pedal here. we go, we do a strike, and then at this point, we're back on. It's not amazing. It's not as good as I would have liked. See, I wanted the motion of this to actually push it forward, instead of just holding still so that this had to retract all the way. Would have been nice if it actually had some pushing force. Moving back. But how do we actually do that? Okay, so theoretically, if I were to do that, what? See how it does send back that way? That's nice. Is there a scenario where this actually pushes it forward? Do I pull that out? Yeah, so in this scenario, it's actually pushing forward as that's pulling in. Okay. So with that theory, wait to move this out. Linkage 3. Now this isn't pulling hard enough. How do I make that pull harder? We almost need to be on this side. Oh yeah, starting to get this. Starting to get this. Okay. So we're going to take link 4. Yes. And bring this guy out closer to the front. Who knows? Because now, oh my god, so okay. So link 4, but now it's getting caught. So that was too much. Right there. But now I need it to stop pulling. Okay, you see what I'm saying? So the further out this is, the more aggressive the pull this way is going to be. But then we're obviously limited down here. Look at that. Look how aggressive that is. What if I bring this in? God, this is hard to control. No, so I liked it better when this was like this and this was like this. I need to figure out how to get this line, which represents the end stop, back here. So what's limiting us there? We're getting bound up. What if I bring this closer? Okay, interesting. So that's a hard stop there. So I need it at this point to be just going over the fulcrum. At this point, this is stretching out. Boom. Boom. But then at this point, it's fully stretched. Which is not what's happening. Because as that passes through, that needs to be the shortest. As that passes through, okay. So if we shrink this down, so that needs to be as close to this as possible. Boom. But see here, it's passing through at this point, which we don't want. Why? That's really nice. That's a beautiful retraction though. Boom. Boom. So at this point, what if this is already here? Certainly don't like what's happening there, but that's what we want. So we want, when we're at this point, basically this is at our, this is going to be straight. This is going to be pulling against this as hard as possible. And then as we come down, I mean, that's okay. Now, see. That's what needs to happen. So all we need is that at this point, the triangle to be that way, and then at this point, the triangle's that way. So what if we put this down here? Does that not work? Guess not. I really want this to pull or to push this guy forward faster. Yeah, see, like that. Ooh. faster. So it's actually raising up. And at that point, we're maxed. This is good. This works good. So at this point, we're right over the dot, and then it retracts. Boom. And then it retracts hard. Okay, that's what we need. Okay. So looking at this. Oh, no. So looking at this, you can see it retracts it really good. Can't go much more than that. And then when we're here, we want this to be basically maxed out. So this is too far forward. This has got to come here. Okay. You know what I mean? Do you know what I mean? That's good retraction, pulling forward, and we should start swinging back down, but no. Why? That is beautiful retraction. Because we've got to wait for it to get underneath before it can start pulling. So we could bring this up further. We're so close. I know I said that at the beginning of this. Let's bring this up and up. Finish. And then I'm going to bring this guy in and down. Broken, but that's a. I was way too high up. This comes down, pushes forward. This is pretty good. I would like to do better. I need this to pull harder. I think if I moved this up, and I think it'll make it less breaky as well. Okay, broken, but Just wait. Let's pull this down. Look at that. I think we did it. So here, we're at the closest point, or I guess here's the closest point, which is fine. Let's just go with that. And then when we get here, a lot of retraction. Okay, now looking from the other side. So we're at the edge of the circle on the red. As this pulls down, that pushes forward significantly. That's our maximum point. I would like the maximum point to be right there, though. But you know what? It's probably going to lock on at that point. Let's go with this. I'm just going to do one thing so it doesn't break so easily. I'm going to move this guy up the tiniest little bit. You are not alone, and I'm still with you. Those on and on, and then in the night. No, 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 no. You're not alone. No, 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 no. Now, when we get the jack back in here, how does the jack play in all this? Okay. How does the jack play into all of this? This launches forward. At this point, hang on, this is all messed up now. Okay. Okay. Oh, this physically can't even be here because of this screw. So let's fix that quickly. Nice. It's going to have to go even more. I don't think this will make a huge difference, actually, which is great. Oh. I see why it's breaking. It's because it's going underneath. Okay, this goes up. Actually, we can come down with this more. Because I went up with it. This is already maxed. So this is already maxed. So we come forward. That's going to push. I'm not liking this yet. Such subtle differences now. See, why is the Okay, so theoretically, if we made that longer and vertical, we should still get some pretty good stuff going on. And then also, it's sort of like in the wrong spot. So we make this longer. Put it there. Okay. So now in terms of the jack, can I make the jack? Not really. So I need this red dial to push on this. All right, I'm gonna call it anyways. I'm exhausted right now. I am exhausted. It's dinner time. But I think we did it, right? Like that. The difference between this and that is huge. Like I might be able to make it even bigger somehow. Oh, I gotta make sure. Yeah, we're still good down on this end as well. No, look at that. That is great. Because in this position, what is our retraction? What do we got on retraction here? I think this. Oops. What do we got? I think this, which is the most we've had. Because then as this comes down, pushes it back up. I just don't really like that there's still some travel here. So let me just mess around with this quickly. Let me see if I can change this. And I got a guess on this one because this one's being weird. So that's where the joint is now. Okay, see, we've moved it inwards. So now, yeah, it breaks now. So I'm not going to worry about that. I'm not going to worry about that. We had it good. I think I'm really happy with this. All right, calling it 4-hour stream. Holy cow. This is it. I'm going to clean this up, start printing it tomorrow. Wednesday, we will have it assembled. Maybe. I don't know if I'm going to do a stream on Wednesday. I've got so much I got to catch up on, so this has taken way longer than I wanted it to. I think it's all good, though. I think this is, this is the whole thing. When this works, it'll be beautiful and awesome and worth watching, and that's kind of the whole point. So let's call it here, folks. Thank you for checking this out. If you're watching this after, I will keep on going with this. We'll get this figured out. Thanks.